So this video is going to focus on compound interest. So first thing, let's assume we have a $2,000 deposit with an APR of 2.25% compounded annually. And so that's what we ended the last video on, but we will get to other types of compounding besides annually. So first off, how much will be in the account for 5 years? Because we know the formula, balance is the principal, 1 plus the rate, raised to the time. So my balance is going to be 2,000 times 1 plus my rate, 0.0225, raised to the 5 years. When I type that into my calculator very, very carefully, I get an ending balance of $2,235.36. So then in part B, how much interest was accumulated? Well, if I ended with $2,235.36 and I started with just $2,000, then the difference would be $235.36, and that's how much would be my interest. Part C, how much would be in this account after 10 years? So balance, 2,000 times 1 plus the rate, 0.0225, raised to the 10 years. I type it into my calculator very carefully, and I get $2,498.41. So, how much interest? Well, if I ended with $2,498.41 and I started with $2,000, then the interest is $498.41. And there's my interest. Now let's compare. Part E. What if it has been simple interest? How much interest would there be? Well, remember, simple interest is principal times the rate times the time. And if I type that into my calculator, I would get interest of $450. So simple interest is $450, compound interest $498. So you earn more than $48 more in the same amount of time just by compounding annually versus simple. Now, most interest is not compounded annually. It's compounded periodically in different types of ways. So I want to show you the formula for this and how it's really not any different from what we've been dealing with. So balance is the principal, 1 plus the rate, divided by how many times a year you compound, raised to the n times t. P, R, and T we're familiar with. N is now the number of times you compound per year. So think about this. When I was doing annually means 1 time a year. So B equals P, 1 plus R divided by 1 to the 1 times T power. Well, what's R divided by 1? R. What's 1 times T? T. And that's how we got the compound annually formula, because N equals 1. So you just have to be aware that if you're doing quarterly, that means N equals 4. That's a horrible looking N equals 4. If you do monthly, well, there are 12 months in a year, so N equals 12. Daily, well, we assume there are 365 days in a year. So, weekly, N is 52. Biannually, that's twice a year. So N is just how many times you're compounding in a given year. Let's do some of these. Let's say $2,000 is invested at 6% for 8 years compounded quarterly. Quarterly, that means N is 4. So, balance is principal times 1 plus the rate, 6% divided by N, raised to the N times T, right? 8 years. So, notice that I put my exponent in parentheses, because if you just put 4 times 8 in your calculator without the parentheses, it's only going to take the 4 as the exponent. It's going to multiply the whole thing by 8. It's really going to jack you up. So if you're lucky enough to have a calculator that will do this exactly how you type it, you should get $3,220.65. If your calculator is a little bit different, you're going to have to start inside and take 0.06 divided by 4, right? Inside. Get an answer. Then add 1. Get an answer. Then raise that to the 32nd power, because 4 times 8 is 32. Then when you're done with all that, you can multiply by 2,000. So those are kind of the steps you would take if you have to type it in one step at a time. Hopefully you have a calculator that you can just type it in as you see it. Just make sure you put your your exponents in parentheses. Okay, so that was 8 years compounded quarterly. Now let's do 8 years compounded monthly. Well, monthly would be n is 12. So same basic, balance, principal, 1 plus the rate divided by the number of times you compound in a year, raised to the number of times you compound in a year times number of years. And when I type all of that in, I get $3,228.29. It's not a ton more than the last one. It's $8 more, but it's the same amount of money, same amount of years. The only difference is how many times we're compounding. Number 3. Now let's go daily. So now n equals 365. So 2,000 times 1 plus 0.06 divided by 365 raised to the 365 times 8 power. And when you do all of that and plug it in, you should get $3,232.02. So again, a little bit more. So what pattern do you see? The more you compound, the more you earn. Which should make sense because every time they compound and they find interest, they add that onto your balance. So even if your balance is only going up 8 cents at a time, every time it goes up, the amount you earn is going to go up. Things just get higher. So the more you compound, the more you're going to earn. Okay, let's do a story problem. Your grandmother bought you a $10,000 savings bond 5 years ago. It earned 0.10% interest compounded semi-annually, which is twice a year. How much will you get if you cash it out right now? And this interest rate is about what we're living in right now. So think about that. We're dealing with balance principal, 1 plus the rate divided by number of times, and then n times t is my exponent. So principal is $10,000. 1 plus my interest rate. Now, 0.1% is 0.001 as a decimal. So I got 0.001 divided by 2, right? Twice a year, raised to the 2 times 5 power. So when I plug that in, I end up with $10,050.11. So we're really only earning $50 in interest over those 5 years, but it's free money, right? You didn't do anything for it. A certificate of deposit requires a minimum deposit of $10,000. Now, that's not necessarily true. It depends how much you're putting it in for. The more you have and the longer you invest it, the higher your percentage rate, definitely. But I had a CD that only had a minimum deposit of $500. So it totally depends on what you're doing. Okay, so you have to invest that for at least 5 years. This CD pays 2.5% APR, compounded monthly. How much will you get if you cash it out in 5 years when it matures? Okay, so balance times 1 plus the rate, 2.5, so that's 0.025 as a decimal, compounded monthly, means n is 12, raised to the 12 times 5 years. All right, so I plug that in, and after 5 years, this is worth $11,330 and a penny. All right, compounding periodically. Make sure that you use your period twice. So monthly means your period is 12. That should be in your formula twice. Once as a denominator, once as an exponent.